And we move on to section B, where it says answer all questions. First one, state the laws of reflection. And what is the first law? So the first law states that the angle of incidence is equal to the angle of reflection in relation or with respect to the normal. And it says with respect to the normal, because when you are taking a reading for the angle of reflection or the angle of incidence, you take it starting from the normal. So your normal is your 90-degree line, and your angle of incidence, your angle of reflection. So you take it here, so with respect to the normal, not as it relates to the media or mediums that would have been used. And law 2 states that the incident ray, the reflected ray, and the normal all lie in the same plane. All right. Now we move on to one property of an image formed by a plane mirror is that it is virtual. State one other property of the image. So there are three that you could make note of. It is laterally inverted, or it is in the same direction. It has the same distance. Let's use it has the same distance from the mirror, or that it is upright. So it asks for one, and there are three here to allow for choices. So laterally inverted, it is the same distance from the mirror as the object, and it is upright. Now state Snell's law. And Snell's law comes from the, well, if you remember the formula, it makes it easier to remember his law. And his formula is N is equal to sine I over sine R, N being refractive index and sine I being sine incidence, sine R being sine refraction. So before we were looking at reflection, but with Snell's law, we work with refraction. And to put that in words, it says the ratio of the sine of the angle of incidence to the sine of the angle of refraction is constant for the given pair of media. And it says, all right, so the ratio of the angle of incidence to the sine of the angle of refraction is constant for the pair of given media, and that constant value would be your refractive index. So based on the medium that is being used, the refractive index for that medium should be constant. And we move on to C. Blue and red light are incident on a perspex block as shown in figure 3. Calculate the angle of incidence for each color of light. So let's put in a normal. And as I would have stated earlier, when calculating the angle of incidence, we take it from the normal. So not from the medium, but from the normal. And starting with the blue light, So know that this half should be 90 degrees in total. And if we were to say 90 minus 53 to find the missing piece, it would be 37. Therefore, the angle reading for the blue light is 37 degrees, and that is being taken from the normal. So the angle of incidence is 37 degrees. And then for the red light, it would be 37 plus 17, which would give us 54. So therefore, the angle of incidence for blue light is 54 degrees. Calculate the angle of refraction of the blue light, given that the refractive index for the blue light is 1.53. So we start off with the formula n is equal to sine I over sine r. And we need to find the angle of refraction, so we transpose to make sine r the subject, and that is sine I over n. So therefore, r would be equal to sine inverse sine I over sine n. But let's work with it like this. Sine r is equal to sine I would be sine 37 over the refractive index, which is 1.53. Therefore, sine r would be equal to 0.39. And sine 37 is 0.6. So let's put that here. Want to put in as much steps as we can to ensure that we get all our marks. So 0.6 over 1.53. And that is sine r is equal to 0.39. However, we don't stop here because we're not trying to find sine r. We need to find r. So r would be equal to sine inverse 0.39. And r would be equal to 23 degrees. So you'd get 22.95, 22.94 something, or something along the lines there. However, I rounded up to get the 23, but you could work with your fraction, your decimal. All right, and moving on to calculating the critical angle. So the formula to calculate critical angle is sine c, where c is the critical angle, is equal to 1 over n. Therefore, sine c is equal to 1 over 1.53. And c would be equal to sine inverse 0.65, because 1 divided by 1.53 is 0.65, and c would be 40.5 degrees. And we move on to question 5. So write the formula to show how potential difference V, charge Q, and energy E are related, and state the SI unit for each quantity. Now the formula that relates all three qualities or quantities are, well, is E is equal to QV. So this is the original formula. Yes, you could transpose to say Q is equal to E over V, or V is equal to E over Q, but the original formula is E is equal to QV. E is energy. Therefore, it is measured in joules. Q is charge. Therefore, it is measured in coulombs. which is a capital C. And V is potential difference or voltage, which is measured in volts, which is a capital V. Now please ensure not to confuse charge with current. Charge is Q and measured in coulombs, while current is I and its unit is amperes. Moving on to question B. A circuit can be used to recharge. A circuit that can be used to recharge a battery is shown in figure 4. Now I says to insert the polarity of the DC supply on the diagram. And with the polarity of the DC supply, the positive terminal of the DC supply should line up with the positive terminal of your AC battery. And the negative terminal should also line up with the negative. Therefore, your positive terminal would be on the right and the negative on the left. Then it says, indicate in the space provided which of the values of 6, 12, or 15 volts would be most suitable for the DC supply. And that would be 12 volts. And it would be 12 volts because the battery itself is 12 volts. Therefore, the DC supply should also be 12 volts to recharge it safely. C. A compact fluorescent light bulb consumes 4.8 watts of power when connected to a 120 volts AC supply. Calculate the current flowing through the bulb. So we use the formula P is equal to VI transpose to find I because we want to find current. So that would be P divided by V. So I would be equal to 4.8 divided by 120. Therefore, I is 0.04 amperes. II. If the bulb is connected for 5 minutes, calculate the charge passing through it. Now, the formula for charge is Q is equal to IT. T should be in seconds. So to convert T to seconds, we say 5 times 60. Therefore, T is equal to 300 seconds. So Q is equal to 0.04. That is current from question I multiplied by the 300 seconds. Therefore, Q is equal to 12 coulombs. If you were to put that 12 is equal, well, that Q is equal to 12 AS, you might lose half a mark because charge is normally and commonly measured in coulombs, but AS is not an incorrect formula because 0.48 times 300 S would be 12 AS. But instead of saying AS, we work with coulombs. And we move to question I. Calculate the energy the bulb transfers in 5 minutes. So we use P is equal to energy over time because we have the power which was given, which is 4.8, and we have time because it says in 5 minutes, which we know is 300 seconds. So transpose to make E the subject. Therefore, E is equal to P times T. E is equal to 4.8 times 300. And that would give us 1,440. And our unit would be joules because energy is measured in joules. Doesn't matter the type of energy, your unit will always be joules. And we move on to question 6. Our final question, which is on radioactive materials, radioactivity. So radioactive materials emit nuclear radiation. List 3 main types of nuclear radiation. So that would be alpha radiation, beta radiation, and gamma radiation. Then it says to identify the type of nuclear radiation which forms part of the electromagnetic spectrum. And this would be our gamma rays. So gamma radiation. Determine the type of radiation that is A, most ionizing, and B, made up of electrons. So the most ionizing would be alpha radiation, and the one that is made up of the most particles would be beta. Now, figure 5 shows a radioactive source which was placed in front of a radioactive detector. The average background count rate is 5 counts per second. With the source in place, the rate rises to 69 counts per second. After an hour, the count rate drops to 21 counts per second. I says, determine the corrected count rates for the activities of the source. So now our initial total count rate, let's say I for initial is 69 counts per second. And the background count rate, let's say B for background, is 5 counts per second. And the corrected initial count rate would be, let us use IC for corrected initial count rate. This would be 69 minus 5. And we say 69 minus 5 because the background count rate is 5 counts per second. And to find the corrected, we have to remove that background noise per se. So this is 69 minus 5. Therefore, the corrected initial count rate would be 64 counts per second. After an hour, the new count rate was 21 counts per second. Therefore, to find the corrected count rate after the 1 hour, we would subtract 5 from 21, and that would give us 16 counts per second. So 21 minus 5, which would give us the 16 counts per second, and this would be for after the 1 hour. And it says to calculate the half-life of the source. So half-life formula is N is equal to N naught. We have half to the power of T over T. Note that N is the 16, which is our corrected count rate after 1 hour, so 16 counts per second. Common T is our time, so the 1 hour. Capital T is our half-life, which is what we're trying to find. And N naught would be 64, which is our corrected initial count rate. So to fill in these values, we have 16 is equal to 64, and half to the power of 1 over t. And while transposing, let's make some space. While transposing, we'll end up with 16 over 64 because we're transposing in steps to ensure that we don't miss anything. 16 over 64 to half to the power of 1 over t. And the 16 over 64 is a quarter. However, to have the same bases, we will say half squared, because half squared is the same as a quarter, and we're doing this so that we can have the same bases, because if the bases are the same, the powers must be equal. So instead of writing a quarter, we write a half squared, which is the same as a quarter, as I was stated, is equal to half to the power of 1 over t. And since the bases are the same and the powers must be equal, we can then say 2 is equal to 1 over t, because the power on the left side is 2 and the power on the right side is 1 over t. So 2 is equal to 1 over t. And to find t, we transpose. Therefore, t would be equal to 1 over 2. So t would be equal to half the hour, which is the same as 30 minutes. So half of the hour, or 30 minutes. Right. So a block of lead is then placed between the source and the detector. The results of the count rates are recorded in the table below. Count rate with the source in place is 69. Count rate with the source and block in place is 32. So what is the count rate with the source and block remove? Now this would be 5. 5 because it was given earlier that the background count rate was 5 counts per second. So if the source and the block is removed, then the only thing that could be measured is the background count rate, and that was given as 5. So it says, the source is known to emit one type of radiation only. Deduce what type of radiation that is. Beta radiation would be the best radiation. 2 reasons. 1, the block caused a significant drop in the detected radiation. However, if it was gamma, then it would block more. So 1 reason, the lead block caused a significant drop in detected radiation. And the second one is that the remaining radiation after adding lead was still substantial. And because of these 2 reasons, it could not be alpha or gamma. If it was alpha, then it wouldn't be able to stop any radiation. And if it was gamma, then it would stop way more radiation. Therefore, the best radiation would be beta radiation. And 2, And with that, I wish you all the best on your upcoming exams.